So after that last video, this case prevails. It's very, very good at cooling. I now want to see if these 180s are actually worthwhile. All of these 140s right here and the 180s on the top, these ones here I'm actually going to remove so that way there's no airflow or anything obstructed. The only fans in this are going to be these two 180s, and then the GPU is going to do its own thing. And that's going to be my baseline to see how these 180s actually perform. Then I'm going to remove the 180s and I'm going to remove all of these 140s from down here, and I'm going to put them on the front using the included bracket. Then I'm going to run the test again and compare the differences between the two. Are 3 140s better than 2 180s? What are the temperature differences, the performance differences? Will it be louder or quieter? Now I have to disclose I'm a little bit biased because with how shady Fractal Design is with this case and their advertising and everything that was going on, the ridiculous prices for fans, I am hoping that the 140s will perform better because you can't buy 180mm RGB fans from anybody else other than Fractal. And with how this entire case situation went down, I don't want to support them anymore. But this case is really good, so I'm going to keep it. But I don't really want to give them any more money. So Fantex makes a vertical GPU bracket that's basically identical to the Fractal one, except it's half the price. To replace this like universal one where it doesn't have anything on the back, so I have to plug the DisplayPort cable through this opening into the card because the adapter that they give you is only HDMI, which doesn't support 165 Hz. So already I found a solution to that. Fantex vertical GPU bracket, half the price, awesome. I actually already bought it, it's on the way. Now I have to do this test relatively quickly because I found a seller who only has 3 2-packs of the Lee Unifans in the white and gray color scheme, which, I don't know, I think it'll work out with like the silver, the white, gray, everything. It'll look alright, kind of make the inside a little bit brighter. But they only have 3 2-packs and I would need 6 of those 140mm fans, so that works out perfect. And I found them for $180 Canadian, shipped, taxes included, right to my door. Now, just to get 6 of the Fractal 140s, it would be $190 plus 13% tax and shipping, which I haven't even calculated. So already just the product alone is $10 more than what I found. These 180s, it's $105 Canadian for a 2-pack, and I would need 2, so that's $210 plus taxes and shipping. So these Lee Unifans are actually the cheapest option to have 6 RGB fans, plus they all connect together, so I actually only have 2 fan headers running out, one from the front, one from the bottom, which means even better cable management. Here's hoping that 140s will be either the same noise level or quieter than the 180s, and that they will perform as good or better than the 180. Now, if it's the other way around, it's gonna suck, but that's what we're here to test. I want to see if these are actually worthwhile. So again, only fans in here, 180s on the front, nothing else. GPU is just going to do its own thing. I'm going to run the benchmarks and we're going to see what we get. That's going to be our baseline. That's gone forever. Okay, so everything's done. Only 180s, nothing else on the CPU cooler. I actually removed the fans on the bottom just because I'm gonna have to take them apart anyway when I put them in the front. Just removed that, and I have the 2 CPU fans stacked up to actually kind of hold the GPU from sagging because it used to be sitting on those fans. So I'll just reset this so we can get a noise level to see what those are at idle. Okay, so we're getting 30.9 decibel at idle. We're at 35, 36, 34, 35, so I'm going to call that 35 Celsius on the CPU. On the motherboard, we have 33, 38, 34, and 32. On the memory, we have 30, 35, 37, and 35. On the NVMEs, we have 34, 33, 32, and the GPU is sitting at 49.6. All right, so let's run this. So we got 35.1. 3D Mark score was 8,898. CPU temperature, we got 59 degrees Celsius. For the motherboard, we got 38, 43, 40, and 37. Then for the memory, we got 36, 41, 42, and 41. On the NVMEs, we got 41, 39, and 38. And lastly, on the GPU, we hit 68.1. So now let's reset this and run CPU benchmark. So we go at 31.8 decibel. Single core was 1,279, and multi-core was 8,490. Now let's check the thermals. So we got 64 in the CPU. We got 38, 44, 41, and 38 on the motherboard. For the memory, we got 36, 42, 43, and 40. NVMe's sitting at 42, 39, and 38. And finally, the GPU at 49.1. Turn real-time protection off. Now we can open Forza Horizon 5. So we have HDR off, 1440p, 165 frames per second, full screen, motion blur off. Everything is automatically set with the Ultra preset. So now let's start the benchmark. So that is 32.7 decibel at 60 frames per second. Now let's just check out the readings. We got 59 on the CPU. Then we come down to the motherboard. We got 40, 45, 42, and 39. For the memory, we got 38, 43, 44, and 41. Then on the NVMe, we got 43, 41, and 40. And lastly, on the GPU, we got 60.8. Now we can turn Windows Defender back on. We will reset these and start Forza Motorsport 7. So we're on the Ultra preset, and it's the native window resolution, so that's going to be 3440 by 1440, and we can run the benchmark. So 31.6 decibel for that one, and 82.5 frames per second. Now we can just look at the temperature readings, then I can swap the fans. So now on the CPU, hit 59 degrees. And then on the motherboard, we got 40, 46, 42, and 39. Then onto the memory here, we got 38, 43, 44, and 41. As for the NVMe's, 44, 42, and 41. Then lastly, the GPU, 57.3. Okay, so that's it for this. I can pull the computer apart and I can switch these front 180mm fans with the 3 factory 140mm fans. Then I'm going to run all these benchmarks again, and I'm going to see if the 140s will perform as good or better than these 180s. Are these proprietary fans really worth the price? Or can you just go with a reputable 140 for significantly less and have just as good or better results? So let's shut this down and start ripping this apart. No. Oh, that was really easy. Oh, okay, so it's just 2 things on the top. You just... done. Okay, well that's actually really easy to take off. Mad props for that. And we can spin this. Oh, we got some free styrofoam. Also a bunch of dust in here. Oh, can you see that? Brand new. It has dust in it. So now the fans are unhooked. Can start removing them. There we are. Just fish those wires through. Just fish the wires through. Come on. Oh my god, okay. Got them. These fans are really heavy. Oh, out with the 180s. And now, how does that bracket go in? Does this have to come out? There's some little screws right here. Because I mean, this probably interferes with the other fans, right? So that probably comes out. These likely... Oh, my computer's still plugged in. Whoops. Let's just unplug that. Yep, okay, good. Everything's fine. So this probably goes something like here, I guess. Yeah, there's a screw hole right there. So I'm assuming that screw hole is for 120s. And if we move it over, that's gonna be for 140s. So we gotta use these inner ones for the 140s. And this obviously goes on the inside. So that means this bracket has to come out. So now I think this is going to perform better solely on the fact that there's gonna be more open area where air is gonna be coming in. So even though those 180s are a much larger fan, the overall surface area of the 3 140s is probably going to have more airflow. If that's true, is it going to be worth extra sound if they end up being louder? It has this little tab right here that goes in to hook into those little slots. Now the next bracket can just go on right here. Again, we're gonna be using these outer ones. So if you wanted 120, you would use this slot right here. That's gonna make it skinnier. So now with this in, the fans can go into the front and then get screwed in through the back. Now we can unhook all of these and put them in here. Up all the way to the top, which is actually going to be the best. So now there's no chance of any air bubbles going in this hose to the pump. So this is actually the best orientation. However, because all of the tests were done with it at the top, I'm going to continue to do it at the top. Okay, so I'm just gonna run a screw through here. What is going on here? Why are you not coming through? Whoa! So now just line that up there. Get it in. Good. Let's screw that in. Perfect. Okay, so that's pretty well in there. This now hangs out in front of the memory because it's a little bit higher than it was before, but that's fine. So now I just got to put the GPU back in, hook these 3 fans up, to the CPU, so it has the exact same control and everything, and then I get to run the benchmarks again, and then see if these fans are louder or quieter, or if they perform as good, better, or worse than the 180s. So this is it. We're about to see if those 180s are actually worth it. Now the only fans in here are the three 140s on the front that you just watched me put in. This does have more surface area of air blowing through the case with 140s as opposed to these 180s. Then it might actually run these fans at a lower RPM because the extra surface area that's properly going through the rad now that everything is actually affixed correctly might actually mean this is quieter. Now right now I can't tell much of a difference. It seems quieter, so we're going to run this again and we're just going to leave it running for about 30 seconds. So 28.5 decibel. So that is actually a fair amount quieter than it was before. So the 140s idle are quieter than the 180s. Now let's look at the temperatures. So we're sitting at 27, 28, 26. So I'm going to call that 27. Now on the motherboard, we're sitting at 34, 40, 37, and 37. Then on the memory, we have 33, 39, 41, and 38. And for the NVMEs, we're sitting at 38, 36, and 36. And lastly, on the GPU, we're sitting at 49.2. Okay, so we'll reset these, and we will run the test. And we got 29.7 for the decibel reading. Now we got a lower score than before at 8,717. So let's see if temperatures were related to that. So right here at the CPU, 57 degrees Celsius. Then onto the motherboard, we have 37, 42, 39, and 40. And onto the memory, we have 36, 42, 43, and 41. Down to the NVMEs, 39, 38, and 39. And lastly on the GPU, 69.9. Nice. So let's run the CPU benchmark. So we got 27.2 decibel for that one. And then we got 1,287 for single core and 8,485 for multi-core. We got 65 on the CPU. And then on the motherboard, we got 37, 43, 40, and 41. Then onto the memory, we got 36, 42, 44, and 41. And down to the NVMEs, we got 39, 38, and 39. And lastly, the GPU at 50.5. So now, just like before, we can disable Windows Defender real-time protection, so that way Forza Horizon 5 will load. What is this? C57 / Forza Horizon 5.exe. C57. What? So just like before, HDR is off, 1440p, 165 frames per second. We're loading this full screen and motion blur is off. And then onto the graphics, everything is set with the Ultra preset. Let's run the benchmark. Okay, we got 29.2 decibel and 49 frames per second. Now onto the CPU temperature, 58 degrees Celsius. Motherboard is sitting at 38, 43, 41, and 42. Memory is at 38, 44, 45, and 43. NVMEs at 40, 39, and 41. And then lastly, GPU at 61.5. So now let's get Windows Defender back on, reset this, and lastly, we can do Forza Motorsport 7. Just like the last one, Ultra preset, native window resolution, so it's 3440 by 1440. Now let's run the benchmark. So we got 28.9 decibel for that one, and 82.4 frames per second. We got 54 on the CPU, 38, 44, 41, and 42 on the motherboard, and then 37, 44, 45, 43 on the memory. NVMEs at 41, 39, and 41. And lastly, to wrap it all up, we have the GPU sitting at 48.9. Alright, so now I have some math to do, so I can figure out which one's actually better. And just like magic, we'll be at the comparison between both of them. So then we can actually see, are 140s better or are 180s? Now the decibel reading I couldn't calculate because I actually forgot to write down the first one in my notes before doing that, so I'm gonna have to go through the footage to get the number to then calculate the number. So I will just put it on the screen. So that'll be the average with the 180s and the average with the 140s. Then we have the CPU temperature. The 180s was 55 degrees Celsius and the 140s is 52 degrees Celsius. So it is colder, which completely makes sense because those fans are directly up against that rad. So it has the most optimal cooling that it can have right now, because before it was sitting up against on the side, so it didn't have direct cooling on it And there's no way to actually affix that to the front of it with these in an actual orientation where it's supposed to be there. Like, I had to use cable ties because there's no way to actually mount it to the front of this. So the only solution for an all-in-one cooler and this case is you have to run 120s or 140s in the front so you can put the rad on the front. And then you could recycle these 180s and put them on the bottom if that's something that you wanted to do. Given that so far these 180s are louder, I'm not putting these back in this case. So now the 140s are quieter and they cool the CPU better, but this is where it gets interesting because the motherboard temperature on the 180s was 39 degrees. With the 140s, 40 degrees. It's running hotter because there's less cross airflow actually reaching the motherboard because the rad is right up against those fans. So now it's blowing air that has already been increased in temperature from the CPU through the case, instead of having that open area to the side where it was getting some fresh air past the cooler. The exact same story applies for the memory. We were at 39 degrees with the 180s. Now we're at 41 degrees with the 140s. And you can see that rad is right in front of the memory. So the heat through that rad is coming out directly into it, causing an overall hotter temperature. Which is interesting because when we take the NVMe's in, it was at 39 on the 180s, and because it's completely open on the bottom, 39 degrees on the 140s. So that directly shows that the 180s and the 140s have identical cross-air cooling when there's nothing obstructing them. So that essentially means that this case with 140s and an air cooler are as good, yet quieter than the case with 180s. 140s are significantly cheaper to buy if you want RGB fans. And again, that direct correlation with the fan sitting there directly on the GPU, and because it's further down getting more airflow across the bottom, whereas the 180s didn't reach all the way to the bottom. And because of that, we had 56.9 with the 180s and 56 degrees flat with the 140s. So when there's nothing obstructing the front, you actually get better cooling with 140s because there is technically more surface area. Learning this right now, kind of feel like I should get an air cooler because then I won't have to put extra fans as pull on the other side of the rad, which will keep the noise levels down, and it'll provide significantly more airflow, keeping the memory just as cold as it was, which will also help with CPU cooling because it'll be directly in line, but then the heat from the CPU heatsink will just be going out the back and not going from the front and covering everything as it goes through. So I think this case with an air cooler, like an NHD15S, that will probably be perfect for this. And I know that cooler, at least the NHD15, I know that can cool an i9. That is one of the only air coolers that can handle the heat. But that cooler is also huge, and the D15S, they've moved the cold plate, so you can actually move it up slightly further, and it only has one fan in the middle, so it also doesn't cover the memory. So that actually might be an upgrade. I'm gonna look more into that, but just given off of these results right now, that's pretty substantial how much of a difference having that 140 further down on the bottom made on the GPU. We had 2 degrees hotter on the memory because the rad is blocking the airflow, and we had 1 degree hotter on the motherboard, again because the rad is blocking the airflow. So if that rad isn't there, this is going to get 39 literally across the board, just like the 180s. These 180s are completely useless. They're expensive for no reason. The only thing is they look neat because they're bigger fans. But now the fans that I'm looking at, the Lian Li Uni 140s, I can get 6 of those for less than only 4 of these 180s. And that will mean that I'm going to have significantly more surface area covered by the fans, which is going to give even better cooling. And these 140s are actually quieter because it has more surface area. So Windows is making them run at a lower RPM because the temperature is being sustained. So they're quieter, they're cheaper, they have better efficiency, and it's going to look better having 6 with full coverage, top to bottom, front to back. Like, my bias aside, because I really didn't want to support Fractal and buy their fans, I'm actually really surprised with the results. Because when it really comes down to it, you can run either. You can run 4 180s and spend the extra money, flex on peasants, because you have these 4 proprietary 180mm fans that are extremely expensive, and you're going to have the identical cooling that you would have with 6 140s. The only difference is it's going to be a little bit louder. Already, it's fairly quiet, so I don't really actually see a huge purpose. So really this just comes down to personal preference, because the benchmark scores that I got are within margin of error, because for some reason I got a lower 3D Mark score with 140s, yet all of the temperatures were almost identical. Geekbench was a little bit better on single core, but worse on multi-core. Forza Horizon 5 was a little bit better with the 180s, but then Forza Motorsport 7 was basically identical. It was, again, 1/10 of a frame difference. So that's within margin of error just running the benchmark. The only thing that I can really see for Forza Horizon 5 that would have been the lower frames per second is that the memory was running hotter, the overall motherboard temperature was hotter, but the NVMEs were the same between both tests. So unless the memory modules getting that hot was affecting it, then it was probably within margin of error where I could just do the test a few more times. I don't know, that's pretty interesting results. 140s are essentially identical to the 180s. There's no way to attach an all-in-one cooler to the 180s, which was the only reason it was having a benefit, is because the RAD that I have was offset. But then you're going to get hotter memory and motherboard temperatures, very mildly, but it is higher than the other test. But then if you have an air cooler, then it's going to be exactly the same as the 180s, which just cost more. So there's really no point to even buy these 180s other than for flexing, because they're extremely expensive. They're proprietary. To have the 4 180s, I guess, is a cool flex. I already did buy the Lian Li fans after these results. I just bought them before recording this last segment. And with the additional money that I saved, I bought a delidding tool, copper integrated heat spreader, and liquid metal. So that's coming. So if you found something useful, like the video, subscribe if you haven't, that's cool. Join the members program if you want to help me pay for all of this stupid stuff that I end up doing, or, don't do any of it. I'm not telling you what to do.